Hello everyone, welcome back to JDCodebase. In this video, we are solving LeetCode 27, remove element using the two-pointer approach, where we swap the with the end. So this method is very important because here order does not matter and it gives us a very clean in-place solution. So let's start by understanding the problem. So this problem says we are given an array called nums and a value val. Our task is to remove all occurrences of val from the array. But there are some important points. First, we must do this in place, meaning we cannot use any extra space, any extra memory. Second, the relative order of element does not matter. And finally, we only need to return the count of elements that are not equal to val. So the first key element of the array should contain the final answer and anything after does not matter. Let's understand this with an example. Input array is 3, 2, 2 and 3 and the value to remove is 3, and after removing all the 3's, the valid elements left are 2 and 2. So the output is 2 because there are only 2 valid elements in the array, and notice that we are not asked to return the array, only the length one. So these constants are small but still important. The array length can go up to the 100, values are very small 0 to 50, and the most important rule is that we must modify the array in place. So extra array are not allowed here. Now let's talk about the idea. Since the problem clearly says that order does not matter, we can use a smart trick. Like whenever we see a value, well, instead of shifting elements or modify, we simply swap it with the last element of the array. And after this approach means after this we swapping, we reduce array size by 1. So this approach is very efficient when the value val appears only a few times, not for a bigger one size array. So this way we avoid unnecessary movement. Let me explain these steps in simple words. First, we start with the two variables I equal to 0 and n is equal to nums.length. And n represents the current size of the array basically. And now we loop while I is less than n. And if nums of I is equal to val, we replace it with the last element of the array. And then we reduce n by 1. But if nums of I is not equal to val, we simply move to the next index by incrementing the I++. So at the end, n itself will be our answer. So it is a two-pointer approach basically. So let's try run this with an example. We have an array 3, 2, 2, 3 and val is equal to 3. We start at index 0 and we see 3, which is the value to remove. So we swap it with the last element. And now the array looks like 3, 2, 2 and again it is the 3 at index 0 we still see the 3, so we swap it with the new last element which is now 2. So now the array becomes 2 and 2 and the last and the size becomes 2 here. Now I reaches the size limit, so we stop here and final length is the 2. That is our answer. So let's move to the code part and write this step in the LeetCode. So here first we create the two pointers. Let I equal to 0 and let n equal to nums.length. So this n will be represent the current valid length of the array, not n minus equal, and start a while loop while I is smaller than n, and inside the loop we check if the current element is equal to val or not. If nums of I is triple equal to val or not, and if it is equal we replace it with the last element, nums of I equal to nums of n minus 1, and then reduce the size of the array n minus minus. And if we do not increase wait, I have to write here n minus minus, yes. So we do not increase I here because the new element at index I still needs to be checked. See, like in this example we replace 3 by 3 and again it comes at index 0 again 3 comes. So for that we have to else and if the element is not equal to val, it means it is a valid, so we move to the next index for that I++. Now in last we have to just return the n as the valid elements, so return n, and the n contains the number of valid elements in the array. So let's run this. Yes, it passed both the test cases. And so let's talk about the complexity. Time complexity is the bigger one because we scan the array only once, and space complexity is the bigger one since we are not using any extra space. See, we are only run the while loop here single time and not using any extra space. And so this approach works best when to order does not matter. Val appear only a few times, in place modification is required, or it is much faster than shifting element again and again basically. So that is for the LeetCode 27, remove element using the two pointer swap with the end method. If this explanation helped you, like the video, subscribe to JDCodebase, and continue with the LeetCode Top Interview 150 series. Thank you for watching. See you in the next video.